So now we have Anireekshith, Prashanth and Manivannan presenting Metamorphic testing for validating machine learning workbench.
My name is Anireekshith. I'm from Software AG. So I am leading IoT analytics group in Software AG, which includes IoT platform called Cumulosity, a machine learning engine called Zementis. With me, I have my team members Prashanth and Mani. Today, we are going to present our paper on metamorphic testing for machine learning workbench. Just to give a brief background about our paper, consider any traditional software testing approach. We have a program and we apply some input to the program for computation. After the computation, the program after the computation of the program, we get some output. Next, we compare output of the program with our expected result. This is called as test oracle. That is, before execution, we know what could be the expected result. However, in machine learning products, we don't know what could be the expected result. So this paper is all about how we are going to resolve this problem. So I will hand out to Mani for the next part. Yeah, Mani, you can take it.
Thanks, Annie, for the quick intro. Let's get going. So here is the agenda for today's session for us. So we will take you through the product line we have. So from the Cumulosity platform, which is our end-to-end IoT platform. We'll talk about the machine learning impact which we make through the product line through using our own applications. We will go through the user journey, how a specific user can use that and how you can take the benefit out of it. We'll also, most importantly, talk about the use cases along with our testing framework. Yes, Cumulosity is an end-to-end device management platform. So it includes various ways to integrate different types of devices. It could be from your smartphone to the industrial robot. So you kind of take all these ways of integrating through multiple protocols we offer. So we offer plug and play way of monitoring these devices. So we give these real-time dashboards from where you can get the real-time insights for the streaming data, which ideally supposed to be the case for IoT, right? We also have predictive and streaming analytic engines, which takes immediate actions because all these things are real-time data. So you have to do this in real time, right? Zementis is our machine learning engine. So we do predictive analytics using this specific product line. So it kind of we require to do this to productionize our models, right? So as you could see in the right side of the screen, the usual data science process goes through way from exploring the data and getting these models to the deployment, right? So machine learning engine achieves that purpose. So we give quickly productionize these models and scale it as well. You could do inferencing in real time and batch mode, which is the core part of deployment. You also achieve through these deep learning frameworks or maybe open source frameworks to develop these models. So we have the industrialized standards, or you can say machine learning standard for two different types of models, which is ONX and PMML models. So these models are kind of allow the people to port or gives more portability for these models actually. So you kind of take maybe something like a AWS SageMaker to develop a model, and you can deploy it in any other deployment engine. So this frameworks allows to achieve that. But how do we get these models, which is pretty important, right? So that's where the machine learning workbench comes into rescue. So this is an end-to-end platform for anyone who want to prototype the machine learning application. So take a case, someone like a data analyst who want to develop the model, he can do it. As a company, we support democratizing the self-service analytics. Our machine learning application is also supporting that. So how do we do that is through something called an AutoML approach, which we'll see in the coming slides. Not only the simpler way of doing the AutoML approach, we also support complex model deployment using the integration of Jupyter notebooks. We do support monitoring these training using the TensorBoard. At the end, we wanted to deploy these models, right, to the deployment engine, which we discussed earlier. So we support one-click deployment. Talking about metamorphic testing, why we need it. So as discussed earlier, we are trying to mitigate the Oracle problem. So most of these machine learning or scientific applications will not have explicit output, right? So you have to kind of go through the relations which it makes. For example, you know, for specific set of inputs, there will be a specific output, right? So you kind of group that as a relation. So generally for machine learning applications, it's kind of hard to achieve these test oracle. As generally, if you take the case of image classification problems, you have to label these images. Otherwise, you will not get these verdict for your solution. So metamorphic testing is one of the software testing methodology which helps us to derive different types of test cases, scenarios using something called metamorphic relations, which is the one which we will discuss in detail. This approach is kind of becoming state of art for testing the machine learning applications in coming years and also will be in future. We'll see a quick example on how this process will look like. We are in pandemic age, right? So this example will suit the purpose. So as we know, we'll take a program where, take this example, it determines the likelihood of your disease. As intuitively, we can make a hypothesis here. As your age increases, your likelihood of your disease also increase. So this is the relation which you are making for this program. And this program is kind of should achieve that relation and it should hold it. If it violates this relation, you could see that your program is not working in the reasonable way. So this approach kind of helps us to gain confidence for our fault detection model. And also it makes sure we are finding the hidden bugs. How we are applying this for machine learning workbench as an organization for us. So we have opportunity to work with multiple personas in our company, from data scientists to including the industrial floor experts, domain experts, to derive these metamorphic relations, because for each type of application, it uses a different algorithms, right? So you have to deal with something like time series data. In our case, most of the times we have to deal with the time series data. You have to depend on these techniques like anomaly detection models and something like a statistical state-based models. You have to use it, right? So for these kind of techniques, as you know, IoT is a diverse, heterogeneous network. You have n number of devices and different types of protocols where you would not see the exact data coming from each of these input, right? So we are kind of moving our thought process to following something called a relation-based approach. So once you find these relations for each type of use case, you could apply it for different types of applications, including the IoT use cases. So this is a platform for us. As you could see from the screen, our machine learning workbench is completely integrated with our cumulosity platform. So you kind of pull all the IoT data, everything from the data lake as well. So what it offers, it's pretty important, right? You can do model retraining, you can schedule the workflows. We also support transfer learning. Imagine something like you using something like a pre-trained model. So we support majorly all the open source frameworks, including the Jupyter notebooks, which we discussed. Let's see the user journey, how it looks like. Machine learning workbench offers us the end-to-way to do prototyping, right? So it all starts with the projects. So you kind of do this project-based development. So you can see in the screenshot, it has the data part, which is the data set, which we need for the machine learning, which you can pull it from the cumulosity, or it could be from one of your data lake. We also have the coding platform to do maybe some simple Python scripting to complex Jupyter notebooks. We also support allowing other types of data, including models, which is pretty important, right? You want to version these models once, and in a cycle of machine learning pipeline, you have to do this. This is a way we are kind of showcasing that we support the Jupyter notebook integration. So from the training progress point of view, and how do we do it is in a simpler way, like in this screenshot, if you see from AutoML approach point of view, we do follow something like a challenger champion way, where you kind of take the best out of one of the different models which is allowed for these kind of data sets. Like for example, in the screenshot, we do different types of modeling with available data set. You can even evaluate this training through the visualization. Once you develop these models, it's very important you do this productionizing, right? So that's where we support the one-click deployment, which I mentioned. And once you do that, the next phase would be the interesting phase of doing the inferencing pipeline, right? So where you would convert your images to tensors, or doing some pre and post processing. All these things are possible through the machine learning engine. So I was talking about the machine learning pipeline. The screenshot here kind of shows that. So we have different ways of dealing with that using maybe the REST APIs. Also, you could use our open source models for ONX and frameworks. We can use that as well. So most importantly, why we do this is also important, right? Because you have to do much of data augmentation in order to evaluate these models. That's where these pre-processing and post-processing helps us. Overall, when you look at the complete picture, right, this is how you could see when it comes to something like an IoT domain, where you kind of see from the left have so much of different types of data coming in, and you wanted to take this data to something like a data lake. And also, as you see that we have something like a streaming analytics platform which does the real-time transformation. This is where our machine learning unit comes in picture, where you do all these data learning approaches. It supports the end-to-end learning, training, and execution. You can even use the historical data for visualization as well. I was talking about the democratization of machine learning, right? So how it helps us. So AutoML is the way to go for like someone like an industrial domain expert to do machine learning. So as you could see, general way of doing modeling involves like you do feature engineering to training and evaluation, which kind of bypassed through something like an AutoML approach. So it kind of takes care of all your hyperparameter tuning, and you kind of achieve all your feature optimization using here. So you could see we use these open source frameworks like scikit-learn and tpot to get something like a common standard model, which would be in PMML or ONX. Let's get into the use cases, which is the interesting part, right? We wanted to show you few use cases. So we are looking at a distracted driver, right? This is one of the problem which has been there with telematics IoT domain, where you get to see these problems day-to-day life. So how we are achieving the prediction of distraction through our machine learning workbench. So as you could see the pipeline of our workflow, we take these data from the real-time feed. Maybe it could be a video feed, or it could be a recorded video, or it could be in image format. You can do all this multimodal transformation in our machine learning workbench, and you kind of require to create a model out of it, right? But where this machine learning metamorphic testing application comes is we had to do transformation for these images. Like, for example, we want to tweak the width of the image. We want to align these images in different way, which helps us to make sure our model works in all the realistic way. So these are the different types of classes of images. You can see this is a multi-class classification problem. You have like from a person driving correctly to someone who is distracted, right? All the different types of classification. But when you get real-time images, you will not have these images, right? You will have some noises associated with it. So just wanted to show when we do this project, we had to apply this model training, right? So this is coming from something like a CNN network. So where we have to apply different types of layering. So this is the look and feel of model training for these use cases. Once you kind of develop these models, you have to apply the transformations for your inferencing as well, right? Where you take care of deployment. So this is the model where you can see we've developed this model using the deep network, and it kind of allows us to do classification here. So how do you do sample inferencing? Once you develop these models, you want to do a quick inference, right? So that's possible through something like a sample image. You can kind of do a quick data prediction. Once you get this, you will get to know if for your specific image, what's specifically happening for your data set. This is the end goal of model deployment, right? We'll get into a more complex use case where you have something like an autonomous car. We all heard about Tesla Pilot, which is one of the autonomous car, and these cars have so much of sensors associated with it, and it kind of pull in so much of data for so many different purposes, including like object detection, something like segmentation. For all these purposes, you have to do. We want to take one of the component for which one of the customer we work with, which is for the object detection. So for this use case, when you see it, right, I mean, like we wanted to illustrate this in an easier way. So just have a look at this image. So we have a car which is surrounded with so many circles, right? These are nothing but the sensor cloud, which kind of allows to detect the distance between these objects. So when you look at this image, there are two what do you call obstacles here. One is the larger obstacle, which can be another car. Another one is a smaller obstacle, something like an maybe a pedestrian path. So you could see this is the usual way you get these way of developing these models, right? But what metamorphic testing allows us to do is like add some probable noises outside this drivable area. So we call this is something like a region of interest, right? So this is the drivable area. Imagine we wanted to add some noises here like this, like in this form. You are making a best practice here of putting these outliers of points in these cloud, which will enhance to make your classifier fail, which is a simpler way of applying something like a metamorphic transformation when you get so many data points in cloud. So I'll move to a case where most of the industry going forward, which is transfer learning. People call fine-tune learning as well, where you get the benefit out of all these pre-trained models. So here is an example of taking this mobile net model. So we have something called a neural network designer, which helps us to achieve that. So this is a screenshot of designing that deep learning network. So you kind of allow to introduce any of your custom layers at the end. Maybe you can add some batch normalization. You could add some dense layers in the end. You can do some max algorithms, activation algorithms. You can introduce that. So this helps of achieve these transfer learning. This is the usual way of showing the prediction for the models when we develop for custom use cases for these algorithms. Let's go into something like an industrial IoT use case. So that's where our company is aiming for the more focus, right? So we are looking at a customer who is like an apparel manufacturer whose aim is to make sure your fabric quality is in good fashion, right? So what you're looking at is a high resolution image where you have to do something like image semantic segmentation, which is kind of the end goal of finding these defects in the fabric, right? So this requires us to use so many deep learning models, different types of processes we have to follow. So what we are achieving is we are making sure our precision of our robot arm is in right way and fine-tuned way. It requires that, right? So that's where we are making sure applying this kind of technique there. So we also employ the predictive maintenance there so that your cutting processes involves the minimized wastage, which is the cost business case. We also wanted to show about the anomaly detection for one of other customer, where we do with something called an industrial robot. So this robot takes care of all this painting of the cars. So we heard about something like a BMW and so many different type of high fashion cars where you have to maintain the superior quality of your painting, right? So what happens is you have to maintain these thresholds, which is very important in real time, so that you kind of make sure it doesn't deviate from that. So we wanted to apply something called an anomaly detection model, which will make sure in real time you find these scores. That's where we do this predictive analytics application. So our test framework, which we are using, is an in-house tool, which is an end-to-end tool where we all start with an agile tester. We have our own repo to maintain all our artifacts from the test suite to the test sets. We can apply all the different types of, we also use something called a domain-specific language, which is a constrained natural language to do these scenarios. We employ something called a Jenkins pipeline, which is the end-to-end for this MMT approach, because as you, one important aspect of MMT approach is we kind of take these data, I mean, like we form these test plans based on the relations, right? These plans will keep on need to be fine-tuned according to your algorithm properties, maybe implementation. That's where you have to do this continuous integration and deployment. What we are talking about is a summary. So summary is, as you were saying about the example where we are adding something like a sensor noise, it's kind of very important you make these noises very realistic, right? That's where the challenge comes, because in real world, such noise can be something like a potentially something like an insect, or could be a dust. It could be in any form, right? So you have to make these what do you call points addition is very important when you add these data. Otherwise, you will pollute the data set, right? So we wanted to make sure when you achieve these experiments, we wanted to make sure this classifier fail accordingly when you change these relations. So it also achieves test optimization, which I mentioned through these relations, where you are creating the follow-up test cases using these relations. But it's important, we also need to consider the overall software testing in order to gain the overall confidence. What are the challenges and takeaways? Metamorphic allows not to evaluate the accuracy of your models, but still make sure the hidden issues for your domain. It makes sure you should get something like a transform data, right? Which should be realistic, which is a challenging aspect. So there are machine learning algorithms helps us for that. People heard about generative adversarial networks to do that. People are following other techniques as well. Data drift is one of the issue when you productionize your model. So that could make your MRs going invalid. So you have to keep an eye on that. So these follow-up test cases, which I mentioned from different MRs, need to be fine-tuned, because you could change your feature as well, right? Feature drift is also one of the concern for these models. So overall, if you see, right, I mean, like potential input space is kind of higher when it comes to machine learning application. So you have to make sure your test selection is pretty important when you discuss this. That's where I was mentioning about multiple personas, which is included for this approach. What are the different types of applications where you apply? So you have something like a chatbot application. People use for something like a compilers where you don't know the expected output. Something like a search engine. Imagine I want to search something and I get some output, but when I restrict the keyword, it should give a smaller result, right? So you're forming a relation there. In NLP case, you can use something like a SOTA model to mask the input, like BERT models. You can use that. You can even apply for medical image segmentation. People use for aerial imaginary drone detection as well. So people do that. These are the references which we want to share it with the team. It is still a novel approach. People are approaching it. So you guys can read about it. It's fantastic to know what's happening at the current era. So we wanted to talk about the questions. So any questions?
Mani, I don't see any questions at the moment.
Okay, that's not a problem.
Yeah.
Wait, I'll wait. No issues.
Okay, thank you so much.
Thanks, guys. I think it's a humble opportunity for us, and thanks for everyone.
Yeah, thank you everyone. Thank you. Thanks a lot.